Yeah, actually, I put this up. So we have a discussion now until about 2 o'clock Eastern time. And we were hoping that most of you would simply have questions because you watched all the videos. We do have a few things planned if people are shy and don't speak up right away. So a couple things we forgot, at least I know I have a couple things I forgot and a couple things that I think did come up in the earlier sessions. So, and I know some came up for Pedro too. So if no one has a burning question, I'll start off with a couple of my things and then we'll just let it evolve from there.
I have a really generalized question.
Perfect.
So, and I was kind of hinting at this on the chat, but I'm trying to put it all together and see when you use which type of program. We're going to also have, it's a little easier with the spring salad to figure out when that gets used. But I was going to ask this about the plenary too. What, is it, because it seems so much easier to use VCell. It's from a biologist standpoint, it just makes sense to me. But it seems from a math standpoint, you're getting much more detail from COPASI. So maybe somebody could make that sort of generalized discussion of, when you switch from one to the other, do you use both at the same time? And I got some good responses on the chat, but it just would help to.
Yeah, so maybe I'll start off with that. So I think you basically got it. There are certain capabilities that the two software systems have in common. When it comes to solving kinetic simulations over time, non-spatial kinetic simulations, either stochastically or deterministically, both software systems can do that. VCell was developed out of cell biology labs. So it was created with cell biologists in mind, and in particular with microscopists who are doing live cell quantitative microscopy in mind. And so that's sort of the basic philosophy behind VCell. That's why we found it so important to include spatial modeling. So VCell can do spatial modeling and COPASI doesn't. VCell also has a rule-based modeling interface, which maybe you'll hear about in a few minutes, that is a little bit more natural for people who are developing models based on the structures of biological molecules. So you'll hear about that in a few minutes. So that's another special feature of VCell. COPASI, and I won't speak for Pedro and Stefan, but COPASI is a mathematical modeler's dream. It has all of these features for analyzing simulation results that VCell doesn't have, including parameter estimation and automatic steady state. I mean, you can do steady state in VCell also, but it's sort of a brute force steady state. You have to run a simulation to steady state to see where the steady state is. In COPASI, it all happens automatically. So there are features in COPASI, but obviously it doesn't do reaction diffusion. And there are features that are the good news is that you can transfer models between the two software systems using SBML. So you can create if you like the user interface in VCell, you can create a VCell model and then export it to this SBML format and then import it into COPASI and vice versa.
I can also add a couple of things. Despite perhaps the impression that COPASI would be a mathematical modeler's dream, mathematical modelers actually don't like COPASI. They normally work with things such as MATLAB and so on. COPASI was really written out of a chemistry perspective. So the reactions in COPASI are really written down as the chemistry. So And it reflects that, because essentially what the choice ended up being is allowing very large systems chemically, so many species, many reactions simultaneously, which if you were to do that in reaction diffusion, then it's a massive computational problem, because obviously you need to calculate hundreds of species per each voxel, per each element of the mesh. But because we are not using the reaction diffusion, it allows us to do a number of techniques which are not, as I said before, it's not so simple to do, for example, sensitivity analysis of a spatial model, because now you have sensitivity of the various species, but it differs in different locations. So now it's like, rather than a big matrix, you have a big matrix at each position in the cell, which is very difficult to calculate. And it's also very difficult to visualize and to conceptualize. So in some applications, it's easier if you can do it in a non-spatial way. And as Padmini was showing, you can use portions of your model in the non-spatial way, for example, for parameter estimation, and then you transfer the results you have, the parameter values and so on, to the spatial system, if you really need to have spatial. Not all problems require having including diffusion in perspective. I mean, some problems don't necessarily require that.
Yeah, which is what I pointed out in my introduction.
Exactly.
That if diffusion is very fast on the timescale of the kinetics, and you can ignore diffusion.
Sure.
Yeah, I mean, VCell does non-spatial models, and it has some limited features like COPASI does. It actually took some of the COPASI code and included parameter estimation for non-spatial models, and it also does some sensitivity analysis for non-spatial models. But if your model is fully spatial and you want to use all those kinds of analytical tools, then COPASI is the appropriate software. If, as I said, if you like the user interface, you can always build your model in VCell, move it to COPASI, do some analysis, then move it back again and add a spatial simulation.